The U.S. Post Office will accept a box only if the sum of height and girth, the distance around the bottom, is at most 108 inches. Find the dimensions of the largest acceptable box with a square top and bottom. So the diagram will look something like this, where the bottom side is a square and it's just a box, horribly drawn. So the bottom edges of the box are going to be X and the height is going to be Y. So in order to find the sum of the height and the girth, is just going to be perimeter plus height, which is Y, which perimeter is equal to 4x. So what we're looking for is 108 equals 4x plus y, and we can say that y is just equal to 108 minus 4x. Okay, and it's asking for the largest acceptable box, so that means we have to look at the volume. So the volume is going to be equal to the bottom edges times another bottom edge, which will be x squared, times y, which y is 108 minus 4x. So 108 minus 4x. And if we expand that, that goes to 108x squared minus 4x cubed, which this goes to 27. So you can take 4x squared out. Actually, we're not gonna do that. So we need to, in order to find the optimization, you have to take the derivative of the volume, which will be 216x minus 12x squared. Now we can factor out a 12. So it'll be 12x is equal to, I'm not exactly sure, 18 minus x, and then we're going to set that equal to 0 to find the points at which, like, there's a max. So 12x equals 0, so x will equal 0, and then 18 minus x equals 0, which x will equal 18. And since the bottom edge can't equal 0, we can get rid of that. And if we plug 18 back up into where we find y, we'll find 108 minus 4 times 18 equals y, which is 72. Yes. 108 minus 72, which is equal to 36, equals y. And the reason why I know this is the largest is because if we take the sign chart for the derivative of volume, then it's going to look like this. We're going to exclude 0 since it's not possible. And if we plug anything less than 18 in, so we'll just go up here and plug anything less than 18. So 12 times 17 is going to be a positive number, and then 18 minus 17 is still going to be positive. So positive times a positive is positive. And then the next one where it's greater than 18, so we'll just plug in 20. So 12 times 20 is positive, and then 18 minus 20 is a negative number, so positive times a negative is a negative, which this means it's going to increase, and then after 18 it's going to decrease, where 18 is the max. I forgot to explain what these answers mean. This means that the bottom edge of the box is going to be 18 inches, and and then the height of the box is 36 inches. So that means the dimensions of the box are going to be be 18 by 18 by 36. So if we add the girth, which is the perimeter, so we just do 4 times 18 plus 36, we'll get 108 inches. And then the area will be 18 squared plus or times 36, which is which is 18 times 18 times 36, which is 11,664 cubic inches.